Welcome to Basic Studio. Dear friends, our topic is function and limit. We have discussed the concept of limit with the help of function. So, you know what is function? It is just relation between two sets, or you can say relation between two variables. We are using just two variables for our study, and our scope is two variables only. So we have discussed much about the function and the concept of limit, and last time we have solved certain problems and we have used presentation, graphical representation as well as analytical representation. So you know how the function works, or the characteristic of the function with the help of graph. Graph depicts the characteristic of the function very nicely and properly, and graphical representation is very simple and understanding mode. Okay, so we have solved algebraic problems. In this section we will use sequence and trigonometric functions. So let us start with the sequence first. Okay, so many times we have the sequences. Sequences means the relation between two elements. Just is a simple relation, that is 1, 2, 3, 4. So relation is just we are adding 1. 1 plus 1 is 2, 2 plus 1 is 3, 1, 3, 5, etc. 1 plus 2 plus 3 plus 3 plus 4, etc. and many more sequences. But in this section we will use only three kinds of sequences. You just look at the presentation. So first sequence, it's a simple one, 1 plus 2 plus 3, okay, up to n. When we use the sequence 1, 2, 3, 4, 5 up to n, and we want the summation or the sum of these elements, so as per the formula, or we can prove that the summation of 1 plus 2 plus 3 up to n, that is equal to n by 2 into n plus 1. So it's a very simple one. The next sequence, that is 1 square plus 2 square plus 3 square up to n square, and the summation of this sequence is n by 6 n plus 1 into twice n plus 1. Okay, and the third one, that is 1 cube plus 2 cube plus 3 cube up to n cube. So the summation of this sequence is n square upon 4 into n plus 1 upon 4. So it is very easy to remember. Look at the first sequence and the third one. The summation of the first sequence is n by 2 into n plus 1, and the summation of the third sequence, that is n square upon 4 into n plus 1. What have you observed? It is just the square of the summation of the first sequence. So you can remember this summation of these two sequences very well. Okay, so you can resemble them and you can remember the sum of the sequences. Okay, so now look at the second sequence, 1 square plus 2 square plus 3 square up to n square, and that is equal to n by 6 n plus 1 into twice n plus 1. So you have to remember this third one, and as you solve the problems or you use these sequences, you will be able to remember it automatically. You won't have to take stress about that. Okay, so now let us solve some of the problems related to these sequences. Okay, so sequences is very important in our mathematics as well as the routine problems, engineering problems and science problem. Now let us use the tabletop. We are using tabletop. So with the help of this sequence 1 plus 2 plus 3 up to n is equal to n by 2 into n plus 1. we will use this sequence in our example. Okay, so our example is this: limit x tends to infinity 1 plus 2 plus 3 up to n upon it is n twice n square. Okay, we have this kind of sequence in the numerator and 2n square in the denominator. So how to solve this? We will use this formula. Okay, it's a simple one. Limit x tends to infinity. Now we will use this summation of this sequence. Okay, and that is n by 2 into n plus 1 and divided by twice n square. Okay, now it becomes the simple expression. Okay, this is equal to limit x tends to infinity. So we have to simplify this expression and with the help of denominator 2n square. So we will write this is n upon 2 into 2 n square, and this is n plus 1 is equal to limit this is n, this is n tends to infinity, this is n upon 4n square. Okay, now we are taking n outside this bracket, so I will write n into 1 plus 1 upon n. Okay, now this is equal to limit n tends to infinity. We are moving from here. Okay, so this is n square, n into n square upon 4 n square, that is 4 n square into 1 plus 1 upon n. Okay, 1 plus 1 upon n, and this is equal to limit n tends to infinity. We can cancel this n square. Remaining part is 1 upon 4 and 1 plus 1 upon n. Okay, now we are applying this limit n tends to infinity, and when it is n tends to infinity, this will be 0. So this is equal to 1 here and 4 in the denominator. So answer is 1 upon 4. So simply we have used the summation of this sequence, or we can say it is a series. When we use 1 plus 2 plus 3, we call it a series, and sequence is 1, 2, 3 up to n. Now we are using again the first sequence here for different example. Look at the tabletop. Example, limit x tends to infinity. Now what we are doing? This is n tends to infinity. We are using n tends to infinity. I am using the same kind of sequence, that is 1 plus 2 plus 3 up to n. Previously, the summation of this 1 plus 2 plus 3 up to n was n by 2 into n plus 1. n by 2 up into n plus 1. Okay. So, in the formula, n square was the key thing. So, I have to use n square here. I am preparing another example. So, I will use it as an n square. Okay. Otherwise, I may use n into 1 plus n. I can use anything here. Suppose you write 5. We are making one example. How to make the example? If you understand it well, you can make the example independently. And I am writing here 3. whatever you like. Okay, if you want to add n here in the multiplication n, so you have to another multiply n in the denominator. I'll write this n square. Okay, so this is the example. We have made it independently without any book. If you understand this first sequence, okay, then you can make your own example. So we have made this example, and I am writing limit n tends to infinity. This is 3n. Okay, 3n. Now the summation of 1 plus 2 plus 3 up to n is n by 2 into n plus 1. That we know the formula. Upon 5. Here it is n square. Another n is here. I am taking it out. So we will have n cube. Okay. So we have taken n out of this bracket or common. So we will have to reuse 1 upon n and plus 1. Simple. So this is equal to limit n tends to infinity. What will happen to this? 3 upon 2 n square. 3 upon 2 n square into n plus 1 upon 5 n cube 1 upon n plus 1. So now we will use this n again and we will take it out of this bracket. So this is equal to limit n tends to infinity 3 by 2 n cube 1 plus 1 upon n upon this 5 n cube 5 n cube 1 upon n plus 1 . So this is equal to, now we can cancel n cube and n cube. 3 by 2 upon 5. So this is limit n tends to infinity 3 by 2 upon 5, that is 3 upon 10, and this is 1 plus 1 upon n upon 1 upon n plus 1. Applying this limit n tends to infinity, this will be 0 and this will be 0. So 1 upon 1, so the answer is 3 upon 10. Now students, I hope that you have understand this use of this sequence. You can make your own example with the help of this formula 1 plus 2 plus 3 up to n, that is equal to n by 2 into n plus 1. And in the sequence, what is important? We are taking n out. So in the numerator it should be n square. Okay. So as in the denominator for particularly this kind of sequence. Okay. Now we will use the second one. Okay. That is 1 square plus 2 square plus 3 square up to n square, and the formula or the summation of the formula is n by 6 into n plus 1 into 2n plus 1. So now you look at this tabletop. What is our formula? That is 1 square plus 2 square plus 3 square up to n square, and the formula is n by 6 into n plus 1 into twice n plus 1. So just like the last example or last formula, here n, another n and another n. So we have 3n. So we must have n cube in the denominator. Okay, n, n, and n. So let us write some example. that is let n tends to infinity 1 square plus 2 square plus 3 square up to n square upon 2n cube plus 4. So this is our example, and our sequence or the series is this: 1 square plus 2 square up to n square. Limit n tends to infinity. What is the summation? That is n by 6, n plus 1 and 2n plus 1. This is the formula for this series upon 2n cube plus 4. So now we will use this n and n, means we will use n out of this bracket and another n out of this bracket. So one n and another n, so n square and another n, that will be n cube. Okay, so I am writing directly limit n tends to infinity n cube by 6. We have taken n out of the bracket, so this will be 1, and here it will be 1 upon n. Similarly here we have taken this n out of this, and 2 plus 1 upon n. Okay, upon, again we are using n cube here, and we want it out of this bracket, so n cube. So this will be just 2, and plus 4, there is no n, so we will have to divide by n cube. So look at this tabletop. So that is equal to limit n tends to infinity. We want to use this one. Okay. And cube cancel. So it is 1 plus 1 upon n and 2 plus 1 upon n upon 6, 2 plus 4 upon n cube. Okay. So this is the our expression. Now this is equal to, now we will apply n tends to infinity. So this will be 0, this will be 0, and this will be 0. So what will be in the denominator? 2 and 1, and means it is 2 upon 6 into 2. So answer is 1 upon 6. Okay. So this is our answer. So now let us use the final formula, that is third one. Look at the presentation. The third sequence or the series, that is 1 cube plus 2 cube plus 3 cube up to n cube, and the formula is n square upon 4 into n plus 1 whole square. So we have the third sequence, that is 1 cube plus 2 cube plus 3 cube up to n cube, and that is n square upon 4 into n plus 1 upon 4. Okay. So let us use some example over here. So our example, limit n tends to infinity 1 cube plus 2 cube plus 3 cube up to n cube upon 4 n raised to 4 plus 5n plus 3. I'm using this. Okay. Here we are applying the formula for this series, limit n tends to infinity, and the formula is n square upon 4 into n plus 1 and square upon 4n raised to 4 plus 5n plus 3. Same, look at the tabletop. That is equal to limit n tends to infinity. We want to use this one. Okay. So here n is common, means here it is a whole bracket square. So n square will come out. So it will be n raised to 4. And here we will use n raised to 4 common. So n raised to 4 is common upon 4. So this is 1 upon 1 plus 1 upon n. This is whole square. Upon n raised to 4 is common, we have used 4 plus 5 upon n cube plus 3 upon n raised to 4. We have used this. N raised to 4 is common, so this will be 4, and here n, so we have to write 5 upon n cube, and here only 3, so we will have to write 3 upon n raised to 4. Okay. So we can cancel this, and limit n tends to infinity 1 upon 4 into 1 plus 1 upon n whole square upon 4 plus 5 upon n cube plus 3 upon n raised to 4. Now we are applying this limit n tends to infinity. This will be 0, this will be 0, and this term also will be 0. Okay, so it is 1 square. And here simple 4. So in the numerator we have only 1 upon here only 4 and another 4. So it is 4 into 4, 16. So limit of this expression or function is 1 upon 16. Hope, my dear friends, hope that you have understood these 3 sequences, and now it is very easy to remember. Okay. So now let us move to the trigonometric functions. Trigonometric function is very important for engineering solutions, engineering problems and its solutions. The important feature of trigonometric ratios and function, that is periodic. And one thing, if we have some periodic functions, we can observe and get data about the practical problems, practical events and real problems. You might have seen TV tower. You might have seen the mobile tower. So what is that? That emits and receive the data, or they emit and receive the waves. And all these waves are periodic. And when you want to learn about this kind of periodic events, periodic waves, you should know about the trigonometric functions. And trigonometric functions describe the periodic events very well and properly. So we cannot go away from the trigonometric functions. Okay, so let us solve some of the trigonometric functions for the limit. Okay, now look at the presentation. It's a very important and basic trigonometric ratio, that is sin theta, cos theta or tan theta. So just now we are talking about the sin theta. We are using this circle, okay? We are using this circle. It may be unit circle or it may not be unit circle, and it is true for any kind of circle. Okay, in this circle, O is the center and points A and B are on the circle. For this circle, we are using various areas. The first area we are using, that is O, B and A. Look at this area, O, B, A. Another area is OCA, that is a triangle. OCA is a triangle, OBA is a sector of the circle. And the third one, triangle is OBP. So we will use all these triangles, okay? Triangles and sector of the circle. So first of all, look at this, OBA. We are using OBA. So we will use this first as a triangle, OBA triangle. Here this line is not there. BA is a, suppose BA is a line. BA is a line. Then the triangle is OBA. Okay. Here BA is missing. So we are using the triangle OBA. Also, when we use OBA as a sector, so area of this sector is greater than the area of the triangle OBA. Okay. And the area of the triangle OCA is greater than the area of this sector OBA. Now the area of this triangle OBA is given by 1/2 OA and BP. Okay. What is OA? OA is a base. OA is this base. Look at this. This is a base. And BP is a height. So this is the area of the triangle OBA. OBA. Now we are talking about the sector of the circle OBA. Now it is not a triangle. We are talking about the sector OBA, and the area of the sector is 1/2 r square theta. Okay. Suppose, so it is 1/2 OA square. OA means that is our radius. So 1/2 OA square and theta. This theta angle is the angle of BOA or COA. This is the theta. Okay. This angle is theta. So the area of the circle is 1/2 OA square into theta, and the area of this triangle OCA, that is 1/2 OA, again it is a base, into height, that is CA. This is CA. I hope that you understand why we have used this. We have this area and this area. Means area of a small triangle, area is a somewhat greater sector, and the area of the biggest triangle OCA. So we have used the area, different area of the different part of the circle and this triangle. So 1/2, that this is 1/2. Now OA is R. OA is radius. Okay, this is R. And BP. What is BP? BP is this. And if we want to write BP, value of BP, that is R sin theta. Value of BP is R sin theta. So R is used over here. So it becomes R square, and this is sin theta. Okay. 1/2. OA square means R. So R square. So this is R square and this is theta. Okay. Now that is less than 1/2 OA. OA means R. Okay. OA means R. And CA. CA is this one. This triangle OCA. What is CA? CA is R tan theta. What is CA? CA is R tan theta. So OA is R, and then R tan theta means R squared tan theta. So now we have another expression, 1/2 r square sine theta is less than 1/2 r square theta, and that is less than 1/2 r square tan theta. So now this 1/2, 1/2 and 1/2, this is common. Okay, r square and r square, this is a common. So 1/2 r square is common in all this expression 1, 2 and 3. So we are cancelling them. So rest of the expression or the value is sine theta, this sine theta. So here it is sine theta. Here we have only theta. So it is only theta. And we have used this, means we have only tan theta. So sine theta is less than theta and is less than tan theta. Okay. Now we are dividing this expression, logical expression, by sine theta. So we divide sine theta, means it becomes 1. Tan theta divided with sine theta, so theta upon sine theta, and tan theta is divided by sine theta, so it becomes 1 upon cos theta. If we change them, okay, if we change this, then it becomes 1. Okay, we are changing them. Theta upon sine theta becomes sine theta upon theta, and 1 upon cos theta becomes cos theta, and now we are applying limit theta tends to 0. We are getting the reciprocal, as well as we are applying the limit, that is theta tends to 0 here, theta tends to 0 here, and here it is only constant. So 1 is less than limit theta tends to 0 sine theta upon theta, and is less than sine theta tends to 0 limit theta tends to 0 cos theta, and when cos is tending to 0, it becomes 1. Okay, and so we can write that some expression is greater than 1 and less than 1. That means this expression is equal to 1. Okay, this expression is equal to 1. So we can say limit theta tends to 0 sine theta upon theta is equal to 1. So it is a very important, this is very important expression or important limit. Now you just look at tabletop. Again we are using it. Look at the tabletop. What is important? Limit theta tends to 0 sine theta upon theta, that is equal to 1. Another conclusion, limit theta tends to 0 cos theta, that is equal to 1, and limit theta tends to 0 tan theta upon theta is equal to 1. How it is tan theta upon theta is equal to 1? Simple. What we are using, limit theta tends to 0 sine theta upon cos theta. Okay, that is tan theta, and we had another theta here. So I am using limit theta tends to 0 sine theta upon theta and upon cos theta. Now we are applying this limit here, sine theta upon theta and cos theta. Okay, so sine theta upon theta is 1 and this is also 1. When theta tends to 0, this also 1, so it is a 1. So these are the important derivatives or derivables. Sine theta upon theta is 1 when theta tends to 0. Similarly, when theta tends to 0, cos theta is equal to 1, and also limit theta tends to 0, then tan theta upon theta is 1. Okay, so you know how it is 1. So with the help of these three values or these three formula, now we will use these three as a formula and we can solve the problem. Okay. Now, example. Look at this example. How to solve it? Limit theta tends to 0 sine 2 theta upon sine 3 theta. It's a very simple example, and we want to find the limit for theta tends to 0. Okay. So what to do? We have to use sine theta upon theta. Okay. So we will convert this sine 2 theta into this form. So I will write limit theta tends to 0 sine 2 theta upon theta upon sine 3 theta upon theta. Okay. So expression, this expression and this expression remains same. Okay. But we want this standard form. Limit tends to theta tends to 0 sine 2 theta upon sine 3 theta upon theta. But what is our formula? Sine theta upon theta. Okay. So here it is a 2 theta. So we must have 2 here. So we can multiply with 2 here. Here is 3 theta. Here only theta. So multiply here. Then we should multiply with 3 here also. So now this is and this one. Both are 1. So what we can write? This, when we apply theta tends to 0, this will be 1 and this will be 1. So remaining is 2 upon 3. So for this example, limit theta tends to 0 sine 2 theta upon sine 3 theta, answer is 2 by 3. Okay. So limit theta tends to 0 sine 5 theta upon sine 4 theta. What should be the answer? Can you say what should be the answer? It should be 5 upon 4. Answer is 5 upon 4. So we can predict that the answer is 5 upon 4. So very simple one. Again, another example. Limit x tends to 0 3 sine x degree, this is degree, okay, upon x. This is a degree. Don't get confused with this. Here what we have used? Radian. Radian was used. Radian. Here we are using degree. Okay. DEGR. This is degree. We are using this. Our formula is for radian. So we have to convert this x degree into the radian. So it should be limit x tends to 0 3 sine x pi upon 180. What will we use to convert this into radian? We will use pi upon 180. Okay, upon x into pi upon 180. So we have converted this degree into radian, x into pi upon 180, and here again x is equal to x into pi upon 180. Okay. this is equal to. So what is important thing now? This is 3. Here we have converted this. So what will we write? 180 upon pi. So we will use this, and so this is equal to, here just a minute, or we can write 3 into pi upon 180, okay, and this will be 1. So this is equal to pi upon 60. So this is our answer. So when it is given in the degree, we have to convert into the radian, okay. Again we want to use the same concept for tan theta upon theta, okay, or we can use some another type of example too. Another example, limit x tends to pi by 2, that is sec x minus tan x, okay, sec x into sec x minus tan x. This is the example, and we want to solve it for x tends to pi by 2. But what we need? X tends to 0 or theta tends to 0. We need this. So we will use this is equal to limit x tends to pi by 2. And what is sec x? That is 1 upon cos x. And minus sin x upon cos x. Okay. So this is equal to limit x tends to pi by 2, and this is 1 minus sin x upon cos x. This is equal to limit x tends to pi by 2. What is 1 minus sin x? Or we can use 1 minus sin x into 1 plus sin x upon cos x 1 plus sin x, 1 plus sin x. This is x. So 1 minus sin x into 1 plus sin x is 1 minus sin square x. So this is equal to limit x tends to pi by 2, 1 minus sin square x upon cos x 1 plus sin x. And this is equal to limit x tends to pi by 2, 1 minus sin square x is cos square x, cos x 1 plus sin x. So we have limit x tends to pi by 2, cos x upon 1 plus sin x. Okay, we have used this cos x, we have cancelled this, so here only cos x and 1 plus sin x. Now if we apply x tends to pi by 2, what is here? Sin pi by 2, and sin pi by 2 is 1, so it will be 2. Okay, but when x tends to pi by 2, cos pi by 2 is 0. Okay, so this will be 0. Answer is 0. So here we have not used tan theta tends to 0, theta tends to 0, or x tends to 0. Instead of, it is a simple kind of our example and expression. Now let us use the another example. Limit x tends to 1, okay, sin pi x upon x minus 1. So it is a different kind of example here. X tends to 1, then it will be a 0 here. So we have to use this value and we will substitute something, and we are using y is equal to x minus 1. Y is equal to x minus 1. So we can say, as x tends to 1, y tends to, when x tends to 1, y tends to 0. Okay. So we will replace this example. Limit y tends to 0. Here it is y tends to 0. Sin pi, and instead of x, what we can use? X is equal to y plus 1. Okay. So it is y plus 1 upon y. Okay. So this is equal to limit y tends to 0. So this is what we can write now. Sin pi, pi into 1 is pi, and plus pi y upon y. Now this is pi plus pi y, means this pi plus something it is in the third quadrant, and in the third quadrant it is limit y tends to 0, it is negative. Okay. And what will we write? Minus sin pi y. Okay. And here we have y. Okay. Here we have only y. Now here it is pi y, so we have to use pi here. Limit y tends to 0 minus sin pi y upon y. I am using pi here, so we should use pi here. So when we apply this y tends to 0, this will be 1 and answer will be minus pi. So this is equal to minus pi. So this is our answer. So here we have many kinds of example, many things, but what is important? The concept of the limit. Once you understand the function, how it works, with the help of analytical discussion and many more examples, we have seen the various kinds of function. Also, with the help of function, we understood and seen the concept of the limit. And with the help of this limit, standard limits, then logarithmic limits, trigonometric limits, algebraic limits, we have solved many problems here. So, I hope, my dear students, you will be able to apply in your practical life, in your engineering subjects, and even when you go to some job, you will be able to use this concept. Okay, thank you very much.